Right. Hi, everyone. So I would like to take this session as a discussion session. We are going to go through a number of questions which might be important for your midterms as well as your finals. So first of all, let's look into question one. Question one basically requires you to form an equation for the demand curve as well as the supply curve based on the sets of data given. So to form an equation for the demand and supply curve, we will need to use the principle of y equals mx plus c. So here in this data, let's say now we look into the demand table and we need to find out that price and quantities belong to which axis. So as we know, price is always on the vertical axis, which we call as y-axis, as well as quantities will be plotted on the horizontal axis, which is the x-axis. So from here, we can actually form an equation. So what we are going to do is this. So I know that y itself is my price, and then x itself is quantities, and my n here is my gradient. How do I find the gradient? So basically we use the formula y2 minus y1 divided by x2 over x2 minus x1. So as such, right, we will take any of the points. Let's say now I take this point. When the price is 28, my quantity is 4, and then to compare with when the price is 29, my quantity is 3. So therefore, I use 28 minus 29 divided by 4 minus 3. I will get the gradient of my demand curve. So I will get -1 for my gradient. And what is C? The C here is basically y-intercept. Now, what does it mean by y-intercept? Let me show you this diagram. Okay, so let's say now we know that price is on the y-axis, Q is on the x-axis, and this is my downward sloping curve for the demand curve, and I know that the gradient is -1. All right, so therefore, now the y-intercept basically referring to the maximum of the price when my quantity is 0. So we are referring to this as the y-intercept. So how do I find y-intercept? So to find that, I will actually substitute one of the point to the equation to find out the y-intercept. So let's say now I take this point. When my price equals 28, my quantities becomes 4. I just plot these two digits into the equation when y equals 28 and x equals 4 and my m equals -1, and I can get my y-intercept, which is 32. So at the end of the day, I just rearrange the terms and I can get this equation. Price equals 32 minus q. 32 is the y-intercept, and minus q, minus actually here is 1. So 1 I didn't write that. So -1 is my gradient, and then q is the x axis. All right, do the same for the supply curve, and then you can compute for the equilibrium price and the equilibrium quantity. Now, question 2 itself is similar to the tutorial questions, but this is a longer version of the question where it includes question C and question D. So let's look into the question 2a. You are given this equation itself. This equation is the demand function for the pork, the quantity for pork. So the quantity for pork is the dependent variable, and it is affected by a number of the variables. So for example, the quantity of the pork will be affected by the price of the pork itself, as well as the price of the beef, price of the chicken, as well as the income. So therefore, price of beef, price of chicken, income, and the price of the pork are the independent variables which will have the impact on the change in the quantity of the pork itself. So therefore, now you are being asked to form a demand function if you are given with the following information. So to do that, you substitute all this information to this equation and you can get the demand function. Very direct, very simple. Now, question B. Question B says that if, let's say, there's an increase of income by $90 a year. Now, you see, let's look back into the original equation. This is the original demand function. And let's look into the income first. How do we interpret this? If we refer to the original equation, it is said that now y here is in the unit is thousand of dollars. So the y is in terms of thousand of dollars, and then my quantity here is in million kilograms. Right, this is the unit, which is very important when we want to interpret it. So now look back to this demand equation, and here basically it means that when there is 1,000 increase of the income, my quantity for the pork will increase by 2 million kg. So this is the original demand equation. What if now the income increased by $90? Now to do that, $90 is not even $1,000 yet. So therefore, I want to find out how much is $90 out of $1,000, because here the income here, the unit is $1,000. Instead of increasing $1,000, my income only increased by $90. So I want to find out how much is the percentage. So therefore, I put 90 over 1,000 equals 0.09. So which means now income only increases by $0.09,000. So it's not even $1,000. So therefore now with this increment of the income, how much would be the change on the quantity of the pork? So for $1,000, it changed by 2 million kg. So if let's say now it increases by 0.09 as the income change, so I use this number, how much would be the change in the quantity? I use this number to times 2, because we just found the relationship based on the original equation. By using 0.09 times 2, this is basically where I can get the change in the quantity of pork. So therefore, an increase in the income by $90 a year causes the quantity demanded to increase by 0.18 million kg per year. So therefore, this income has led to a rise in the quantity demanded for the pork, and this can be represented by the rightward shift of the demand curve. So this is one of the example which you might be tested in your midterms or your finals. And moving on to question C. All right. Now, question C says that, let's say now there's a change in the price of beef. In this question, price of beef, the beef itself is the substitute for the pork. All right. The price of beef decreases from $4 to $2.91. So how much will it affect towards the demand for the pork itself? We can use the same method just now. Actually, there are two methods to do this question. I use the method same as just now first, like for this one. So based on the equation, we know that, okay, we know that price of beef is here. So every increase in the price of beef will lead to 20 million kg per million kg increase in the pork. So therefore now there is a change from 4 to 2.91. So this is the change in price of beef. So when I extract this from the original equation and then put the number over here to find out the change of the price of beef, which means 2.91 minus 4 times the 20, I will get this negative 21.5 million kg. So which means that with this decrease of the price of beef from $4 to $2.91 times my coefficient of 20, which means that the quantity of pork will drop by 21.8 million kg, drop by 21.8 kg, because now beef becomes cheaper. So people will start substitute beef for the pork. So therefore, now in this case, we know that the quantity of pork will drop by 21.8 million kg. There is another way to do this as well. First, I differentiate the quantity with the respect of price of beef. So which means that right now, I know that every time when there's an increase in the price of beef, the quantity will be affected by 20 units. So I want to find out initial how much would be the quantity of pork when the price is $4, when the price of beef is $4. So initially, the quantity of pork is at 3 million kg. However, when the price of beef becomes cheaper to $2.91, I times back 20 coefficient, I get 58.2 million kg. So from 80 to 58.2 is the decrease of the demand for pork. This is the same amount. All right. Now moving on to question D. Given the inverse demand function for pork from question A is P equals 13.55 minus 0.05 Q, how much would the price have to rise for consumers to want buy 8 million fewer kg of pork per year? So now they are asking how much should be the change in terms of the price if you expect the consumers want to buy 8 million fewer kg of pork. So which means that I extract this again from here. So here this equation, if you want to interpret it, is basically saying that for every increase in the quantity, the price has to be dropped by negative 0.05. So now if you expect the quantity to drop by 8 million, so basically it's negative 8 times the coefficient is the price that you need to drop in order to achieve the goal. So therefore now when we say that the change in Q is negative 8, we expect 8 million fewer kg of pork times the coefficient negative 0.05, which means the price has to drop by $0.40 in order to achieve that the consumers want to buy 8 million fewer kg of pork. Okay. So basically, this is how you refer to the equation to extract the information or data as well as for the interpretation. You will learn more of this and you will continuously using this throughout your whole module and even for your upcoming modules such as econometrics or intermediate macroeconomics. All right. Now, question 3, question 4 are very direct where you have already known how to actually calculate for the equilibrium price and equivalent quantity and how to get the world supply curve and etc. So now I'm going to look into questions on elasticity. Now, question on elasticity is really, really important as your lecturer or your tutor really love testing you on this concept. Now, first of all, for elasticity, you need to know the formulas. So let me show you some important formulas. Okay, so this is the formula for the PD. As we have learned from the microeconomics, when we calculate PD, we use the percentage change in the quantity demanded over percentage change in the price. So I can make it into numerical terms. Basically, is percentage change in quantity divided by quantity over change in price divided by the price itself. Basically, it represents the formula that we have learned. So from here, I can rearrange the terms. I want to put the change itself in one part and Q and P on the part. So therefore, I make it into this equation. This one, derivative of Q and derivative of P. This derivative is basically represent the change itself. So it's the same as a triangle symbol. So now this is how the equation being derived for the PD. So same goes to XED, YED, and PS as well. So therefore, if today you were being asked to compute XED, YED, and PS, these are the equations that you need to bear in mind in order to calculate your answers. So I'm going to use some of the questions to show you some of the examples. Let's go back to the screen. Okay, now this is a very direct question. If the price of eggs increased from 1.50 to 1.70 and the quantity demanded decreased from 25 to 20, what is the PD? So use the formula and plug in the numbers and you can get the answers very, very easily. So because from here, you can already compute the change in the quantity as well as the change in the price itself. and then times the price and the quantity, the initial one, that times the initial price and the initial quantity, and you will get the number. Now, what if today you are not being given this direct information? I want to show you this example, question 10 itself. Using the formula given, if the equation for the demand for shirt is Q equals 200 minus 10p, what is the PD when the price equals 10? Now here you may not be given much of information. You might be asking, where do I get this change in Q over change in P? When we talk about change in Q over change in P, is basically referring to the gradient, to the gradient of the graph itself. So basically we are referring to the coefficient. So let's say now we take this equation, we do not have the change in Q or change in P, but we know that the coefficient is negative 10. So the negative 10 itself is the number that we could plug in to replace the change in Q over change in P. Now, why is that so? To understand this equation, we interpret this way. For every $1 increase in price, the quantity will drop by 10 units. So this is the interpretation. So the 10 unit itself will definitely be always be the change of the quantity. So therefore now we can make it as our gradient or our coefficient to replace this change in Q over change in P. So here, go back to the same. Basically, I got the price is 10, and then my quantity is 100. How do I get my 100? Because I substitute the price equals $10 into the equation, and I got the quantity demanded equals 100. Because when my price is 10, I just put in the number and I get quantity equals 100. So therefore, with this, I can get this answer. When my PD equals 1, basically we are referring to unitary elasticity of demand. All right. Now, same go to question 11. All right, question 11 is even more direct because they already give the percentage change for you to compute the PD. So you can refer this as your answer. All right. Okay, question 12. Question 12 is still the same. It's still part of the PD questions, but here you are required to actually compute the income elasticity of demand, basically YED. So again, just use back the formula and you can get the answers. Okay, but the thing is this, same here, yeah. So because you are not being given the change in Q over change in Y, this one. So therefore, always remember to look into the coefficient. Look back into this equation. That's why I would say the understanding of the interpretation of the function is really critical when you want to do your calculation or your analysis. So from here, when we want to do YED, we focus on the income variable. So this variable, it means that for every increase in $1 of income, the quantity will increase by 0.2 units. So therefore, this 0.2 unit will be the coefficient that you will put in to as a representation of the change in Q over change in Y. All right. And then now here in this question, you know that income is 1.5. Okay. And then my quantity is 1,275. Okay. And you will get a number. To get this 1.5 is basically I substitute all the variable numbers into the equation so that I will be able to get this 1.5 for my income. So basically here is just testing you about the normal algebra so that you can actually calculate your elasticity. All right, you can try this out and see if you can get this answer. All right, let's move on. All right, now here another question is on the PD and XED. Same here, just get the numbers and plug in and compute the answer. So you try to do it and see if you can get this answer. If you can get it, which means that you have understood this PD, XED, and YD concepts pretty well. All right, let's move on. Question 13 is also another elasticity question. All right, now I would encourage you all to actually keep practicing on the elasticity questions, yeah, because there's a higher chance where you will be tested in midterms as well as finals for your elasticity questions. Okay, so again, plug in all the numbers into the equation to get the to get the information, to get the full information. All right. So for example, to find PED, now again, same here, you don't have the change. So therefore, you refer to the coefficient. So when we talk about PED, we refer to the price of the product itself. For every increase in the price, the quantity will drop by 5 units. So the -5 is my coefficient. I put it over here. And then my price itself is 80 as taken from here. And then 2008 is the quantity which I extract it from the substitution of all the information to this function, and I got the amount. And that's where I can get the figure for my PED, -0.14. So since it is less than 1, we know that the demand for this product is inelastic. All right, now next go for XED, cross elasticity of demand. And same here, do the same, and then you get the coefficient and times the amount. Once you get the amount, you may be asked to actually indicate what type of product would it be. So if you get an amount in terms of positive number, we know that it's going to be a substitute for under the XED. Whereas if you get a number in terms of negative, we know that it's a complement. So to understand the types of goods after you get the information or after you get the number from your calculation is still very important. All these are actually part of the basic foundations from your microeconomics. So it will be best if you actually refer back to your microeconomics if you have forgotten some of the key concepts about the elasticities for your analysis purposes. All right. So pretty much that's all for chapter 1. And I would like to actually discuss one more additional questions with you all. So let's say you are given this question, right? Now, question A asks you to calculate equivalent price and equivalent quantity. This is very direct. You can just make it into, okay, first of all, these two equations, one on the demand, this is for the demand. That's why you can see the demand over here. And this is for the supply. When my price itself is in the left-hand side, right, we call it as inverse demand function. All right, to be on the safe side, I will always encourage students to change to demand function. Demand function is always start with QD or QS. When your function start with P, right, it is an inverse demand function or inverse supply function. We have the word inverse. So therefore, to be on the safe side, change to quantity demand and quantity supply function, and then you can calculate easily. So basically, you can refer to this piece of information that I've written. All right, so you get quantity demanded and quantity supply, right? Okay, now okay, for question B, it says that if there's an imposition of tax of $10 on the product, how much what will be the new equivalent price and quantity, as well as what will be the tax revenue. Now when there's a tax imposed, right, it's going to affect the supplier, all right, because government will collect the tax government will collect the tax from the suppliers. So it's up to the supplier to actually either bear all the tax or share the incidence of tax with the consumers. So at the end of the day, we know that the tax is collected from the behalf of the producers. So in this case, this $10 is going to affect the price of the product, and we assume that it's going to affect the producers first. So how I'm going to do is this. Since I got this equation QS equals -30 plus 0.5P, right? My quantity supply function, because now I got one quantity demand function and one quantity supply function. So with my quantity supply function, I'm going to look into quantity supply function is because we already made an assumption that the tax itself is going to affect the supplier. So let's say now the price of the product is let's say now the producer selling a product at the price of, let's say $20. All right, let's say initially before the imposition of tax is $20, but because of the imposition of tax, government has to take a certain portion of the amount for the purpose of the tax. So from the initial $20, right, let's say the $10 of the tax will be taken. So this $10 is taken from the initial $20 that's being priced by the producer. So therefore, we minus the tax from the initial amount of the price. So therefore, looking back into quantity supply equation over here, the price itself, this price has to be taken by the amount on 10, which is for the tax purposes. And therefore, with the tax of $10 per unit, my quantity supply will become like this. I written this way. So now you can calculate and get the new quantity supply equation. You can get the new supply function. So this is your new supply function. And then now with your initial demand function and your new supply function, very simply, you can get your new equilibrium price and your new equilibrium quantity. But the thing is this, the question requires you to actually calculate the tax revenue as well. So as we know, the tax itself is $10, and then now you have sold 26.25 units, 26.25 units. So using this new quantity times the amount of the tax, you will get the tax revenue itself. Moving on to chapter 2 on the consumer choices, the first question will be on the indifference curve. Why indifference curves are convex? To answer this question, there are 3 critical points in your answer, in your script. The first one will be willingness to trade. When I talk about willingness to trade, I'm basically referring to the fact that when the consumer has more of one particular good, he will be willing to trade more of the good for another good that he doesn't have much. So therefore, we refer this to the willingness to trade, and it can be backed up by the concept of diminishing marginal rate of substitution, diminishing MRS. Right? So therefore, this leads to the convex curve of the indifference curve. While at the same time, another reason why indifference curves are convex is because both items are imperfect substitutes. So these 3 key points are very important in your answer when you were to answer this question. Now going for question 2, why difference curves do not cross? To answer this question, I would like to go through the concept of the impossible indifference curve from your slides. Let me show the slide here. All right. Now, these are the 3 impossible indifference curve, and let's go to the first one. Indifference curve do not cross with each other. So as we know, indifference curve shows the bundle of goods that give the consumer same satisfaction. So like for example, on the blue curve itself, point E and point A should give the same satisfaction to the consumer, whereas the point E and the point B on the red color line should give the same satisfaction to the consumer as well. However, when you cross 2 lines together, it actually contradicts with the concept of the indifference curve, because when you compare between point A and point B actually highly prefer than point A because of more bundles of goods under point B. So therefore, following the concept of more is better, this actually contradicts with the principle of the indifference curve, because point B actually gives higher satisfaction than the point A. Now going for the second impossible indifference curve, indifference curve should not be upward sloping. Why is that so? When it's upward sloping, it doesn't give the same satisfaction to the consumer in terms of the bundle of goods. Like for example, in this scenario, point B actually has more combination of goods than point A. So therefore, point B should give higher satisfaction to the consumers than the point A itself. And therefore, this overrules the principle of the indifference curve again. Now, thirdly, indifference curve cannot be thick. When it is thick, it will cover different points of the bundles of goods. Like for example, in this scenario, this thick indifference curve has covered point A and point B. But point B actually consists of more of the burritos and pizzas in this scenario, and therefore it should be preferred more than point A. So therefore, once again, this overrules the concept of the indifference curve. All right. Back to our question. All right. Moving on to question 4. Question 4 is more like the final exam type of the theoretical question. You might be tested this in your finals to test on your theories on the isoquants or even the indifference curve. And then usually this could be a 10 marks or 6 mark question. So I would like to actually leave this as the practice for you for your finals. All right. And then let's look into question 6. Question 6 is to test on your concept of equimarginal principle. Now, aside from the use of language in getting the optimal bundle of goods to maximize the consumer's utility, there's another formula which is very important. It's called equimarginal principle. Let me show the screen over here. Equimarginal principle basically referring to this piece of slide where your marginal rate of substitution should equal to the marginal rate of transformation. When I talk about marginal rate of substitution, I refer to the slope of the indifference curve. And when I talk about marginal rate of transformation, it refers to the slope of the budget line. So once I got this equation, I put the item Z on one side and the item B on the side, which means that let's say I take this example, marginal utility of Z divided by price of Z, because I move this over here and I move MUB over up there. It means that when the marginal utility of my last dollar spent on the product Z equals to the marginal utility derived from the last dollar spent on the product B equal to each other, which means that I've achieved my maximum of the satisfaction. Here in this case, now you are being given the marginal utility as well as the price of the items. So you can just put it into the equation and equate to each other. So for example, in this scenario, you can put into this equation 10 over 10 equals to 5 over 2, right? However, in this case, you realize that it does not equal to each other. And in fact, the marginal utility per dollar is greater for cookies than the books. Now, in this scenario, it doesn't equal to each other, which means the consumer has not yet maximized the utility. So what he should do is he should choose the item that give a higher marginal utility per dollar spent. So therefore, in this case, he should actually consume more of the cookies than the books in order to bring back to the equimarginal principle. Now, students always make a mistake over here. They might think that, oh, because the marginal utility per dollar spent on the book is actually lower than the marginal utility per dollar spent on the cookie. So therefore, they should actually consume more of the book so that the book's number will become higher and then the cookies will become lower and achieve equimarginal principle. We do not see in that way, yeah, because here we are referring to the item where it still give, we're still referring to the item on which item give the consumer higher marginal utility per dollar. So like in this case, if the cookie is still giving a higher marginal utility per dollar, which means the consumer should still consume more of cookies rather than the books. So this is one of the common mistakes done by the student. All right. Now, moving on to question 8 is still a question to test on the equimarginal principle. Now, in this question, you are given the utility function as well as the price of the items. However, in this case, you are not being required to do language. You just need to do simple equimarginal principle. So very simple. From this utility function, you derive the marginal utility for the product 1 as well as the marginal utility for the product 2, and you equate to each other. Now you have found the marginal rate of substitution. So now this is your marginal rate of substitution, and since you have the info on the price of items, you can form your marginal rate of transformation, which is 1 over 2 in this question. So now once you equate each other, you can start from your equimarginal principle, and once you get this information, substitute this information to your budget constraint, and that's where you can find your optimal bundle of both items with the use of the equimarginal principle rather than the language, if let's say you are not being required to do language in the particular question. All right, but most of the time your midterms or even your finals might require you to do language. So this question is just to show you how the equimarginal principle works. All right. Now, question 9, if you do realize, is similar to your tutorial question, but this is more of the advanced version of the question. Because in your tutorial, you have been given some information that is your calculation process. But in question 9, it is a situation where you are only being given utility function, but without any information on the price or even on the items, even on the units consumed. So they are basically asking you to find out how much of the item X to be consumed with just the information on the utility function. Now, in case if you're wondering how to answer this question, right? This question basically requires you to use your maths formula where negative b plus minus square root b squared minus 4ac divided by 2a is a maths concept where you use this formula to actually derive the number of the item X to be consumed. And once you use this formula, you will get both answer, one on positive and one on negative. So you choose the positive one. So, but however, this one just to show you that in the scenario or in the circumstance where you are not being given much information, then perhaps we need to bring in some of the maths concept. But in your midterms, as far as your syllabus is concerned, your midterms might be more of like this. Let me show you the tutorial. Your midterms might be more like this. If they were to test you on your utility, they might give you tables and they ask you to derive marginal utility, etc., and then use the language to calculate the optimal bundle of goods. All right, so that one is just to show you as a sample. Okay, let me go back to the question. Okay, now before we go for question 10 onwards, I would like to actually go through some of your slides. Okay, let me go through the slides. Today, when we want to talk about the shift of the curve, all right, when we want to talk about the shift of the curve, let's say now there's a change in the price of the good, or when there's a change in income, etc. Usually when there's a change in the price of good, there will be a total change in the quantity demanded of the items. And when we want to illustrate the graph consists of the substitution and the income effects. Let's look into this slide. When we talk about substitution effect, it's basically referring to the situations where when the price increases, let's say now price increases, you will consume less of the expensive products because you are substituting away from the expensive goods towards the cheaper goods. So we call it as substitution effect. On the other hand, when we talk about income effect, it's basically saying that now you have more real purchasing power, you have more real income, and therefore you have a higher purchasing power or higher capabilities to purchase more of the goods. So now in this scenario, let's say if the good is normal, is the normal good, then you will consume more of the products. If let's say now the product is inferior goods, therefore you will consume less of the product when you have higher real purchasing power. Okay, so now I'm going to show you some of the graph to illustrate the substitution and income effects. So now let's say in this scenario, you are looking into the music tracks as well as the live music, and this is your initial point. Okay, now let's say there's an increase in the price of the music track, so which means this becomes more expensive. So when this is more expensive, the final outcome on your graph should be that you will only be able to consume less of this but still the same on this. So which means that by illustrating on the budget line itself, my budget line should shrink inwards on the music track items, pivoting to the live music point itself. Now, when for this shift to happen, right, it actually consists of substitution as well as income effects. Now, when we talk about substitution effect, we refer to the first point E1 here. When the price of music tracks becomes more expensive, you will start substituting the product itself. You will start substitute the live music, which is cheaper, to replace the expensive music tracks. So which means now I can actually use this new line L prime budget line curve to illustrate the substitution effect. So now, which means that instead of consuming this amount of music track and this amount of live music, I consume less of music tracks, but more on the live music. All right, this is the substitution effect. There's another effect called income effect. So the income effect is represented by the parallel shift of the curve itself from E prime to E2. So here is the income effect. So since now the price of the music track has become more expensive, even though you have substitute towards the cheaper live music item as compared to the expensive music tracks, however, the increase of the price will still have an impact on your income. So therefore, this actually limits your real income or your real purchasing power, and therefore this reduction of the real purchasing power will be represented by the parallel shift of the budget line from this E prime, from this L prime of the budget line to L2. So therefore, this is the income effect. So when we draw the diagram, right, it usually consists of the substitution and the income effects, which you need to bring in your analysis or your explanations. Okay, now let's look into another example over here. You are comparing between the rice as well as all other goods. All other goods can include chicken, pork, meat, etc., which are slightly more luxurious as compared to rice. So initially, you are actually consuming at this bundle of goods, which means this amount of other goods as well as this amount of rice. Now, with a decrease in the price of rice, right, is going to actually give you the ability to consume more of the rice, all right, while the price of other goods remain unchanged. So therefore, the final outcome would be that your graph will shift outwards for the rice, pivoting to the initial point of the other goods remain the same. So therefore, here again, we are going to look into the substitution and income effects. So initially, you are consuming this amount, which can be represented by E1. Okay, what happened is when the price of rice becomes cheaper, you will actually consume more of rice and less of other goods, so as represented by this E prime. When I talk about substitution effect, now listen this, when I talk about substitution effect, we are always still referring to the same indifference curve. So we are just moving around on the same indifference curve because it gives me the same satisfaction, and I'm just substituting one to another because of the price itself. So when the price of rice has become cheaper, it actually gives me a higher real income, a higher retained real income, or a higher real purchasing power to consume both of the items. So therefore, now since the price of because of the decrease in the price of rice, it actually gives me higher real purchasing power that allows me to consume both of the items. So therefore, in this stage, it can be represented by the parallel shift of the of the budget line from L prime to L2. So from here, my indifference curve shift upwards. And now on this new indifference curve, again, I can still choose the bundle of goods, either more of other goods or less or more of rice. But since now we assume that rice is slightly inferior as compared to other goods like chicken, pork, and meat, etc. So in the new indifference curve, the new budget line, because of the income effect, I will go more towards other goods rather than the rice. So therefore, now at the end, I consume the bundle of goods as represented by E2. All right. So this is just to show you that the income effect as well as the substitution effect on the graph itself. So back to the question. So back to the question. So here, I would like to look into question 11. So question 11 is just a sample on what we have explained just now. You can try it out. I have provided the answers for you. You can try it out and see if you understand the substitution effect or even the income effect. Okay, and then question 12 question 12 was a past year question for your module, and for this question I don't expect you to try it out for your midterms. Just keep this for your finals, and this is how your final questions will look like in your section B. Is 20 marks questions, all right, and for your finals there will be one more question on angle curve, so perhaps that you will need to revise your angle curve for your final as well. And one of the sample question will be like this. Question 13 will be incorporated to your final questions if let's say they were to test you angle curve from the utilities questions. Okay, and then lastly, language is very important for your utility part. So let's say now I take question 15 as an example. So you are given with the income, the price of X, price of Z, and then now you are also being given the utility function. You are being asked to find the optimal bundle of goods using the Lagrange method. So let me show the workings. Okay, so here first you have the utility function, and then form your Lagrange equation, and then do the differentiation to get 3 equations. All right, and then after that find lambda for equation 1 and equation 2, and then equate lambda to each other, and you get this information. Substitute this information to your budget budget constraint, all right, and you get the x. After you get the x, you find the z, and then if you are being asked to find lambda, substitute x and z to either one of the equation, either equation 1 or equation 2, and you get lambda. So this is how you do your Lagrange equation. You can take that as the sample, and then so for chapter 2, these are the important questions you need to revise before your midterms. So for chapter 3 and chapter 4, which concerns about the production and cost for the short run and long run, there are only few questions that I would like you to try for your midterms as far as the syllabus is concerned. So therefore, for chapter 3, you will just need to practice question 2 and 3 as highlighted here, all right? And then for chapter 4 on the cost, you will just need to practice question 1 and 2. So usually these are the questions that you might be tested for your midterms, especially like question 2, where it's just a direct question where it just requires you to use the formula that you have learned from microeconomics to compute the equation, right? So let me just show you the answer. So for chapter 3, the question 2, you are being given the equation, all right, and you need to find the APL, average product of labor, and MPL, marginal product of labor, and what are both of the numbers when capital equals to 16. So since this is a Cope-Douglas question, in terms of the differentiation and all this is still the same. This is the formula. Like for example, to find average product, you use quantity divided by L. And to find out marginal product, you use the dq over dl, change in q over change in L. So again, it just requires your knowledge from your simple calculations. It's just that when it comes to question C, when capital is becomes 16, so you substitute the 16 to the equation of the quantity function, and you get a new quantity function over here, and then use this new quantity function to compute your APL and MPL. So this is how you do your question 2 of this chapter. Then going for question 3, again, you are being given this quantity function. Okay, and then you are required to find out the value of labor that maximize the output, find the value of L that maximize the marginal product, and find the value of L that maximize the average product. So to find out the L that maximize output, so you need to understand this graph very well. Okay, this graph. You see, this is my total output, right? This is my total output. And this is my marginal product, and this green color line is my average product. So now, if you do realize this is my maximum of the total product. So therefore, if you do realize when my total product is on the maximum, my marginal product equals to 0, right? Equals to 0. My marginal product equals to 0, hits on the horizontal axis equals to 0. So it means that when my marginal product becomes 0, my total product is at the highest. All right. So to answer that question, I find out the marginal product from the equation and then sets it into 0, and I can calculate the L. Okay. Now for question B, find the value of L that maximizes marginal product. Since I have this marginal product equation, what do I do? So what is maximum of marginal product? When I talk about maximum, it's basically dy dx equals to 0. So if you refer to this graph, this blue color line is marginal product, and this green color line is average product. Dy dx equals 0 is the maximum point over here, as I shown on my arrow here. Dy dx is the maximum point. So when my marginal product becomes 0, dy dx becomes 0 means the maximum point. Same goes to green color curve itself. When average product is on the maximum, it means that my dy dx equals 0, the maximum point. So therefore, what I need to do is, since I have the marginal product equation, I derive this equation, which means that I differentiate the equation on this marginal product with the respect of L. So therefore, now I get the dy dx equals 0, which means the maximum of the labor. And the same go for your question C. Okay. Moving on to your cost questions. So let me show you the answer. Okay, so here you are being given the cost function, and you are being required to calculate for all these costs. So for fixed cost, you will just take this number that is not affected by the quantity produced, which is 400. And average fixed cost, you will just take the fixed cost 400 divided by Q, the quantity that you produce. So this is the new equation. ABC is you use the variable cost divided by Q, so as shown here. And average cost is basically you use the whole equation to actually divide it by Q. And when we talk about marginal cost, you just differentiate the cost function with respect of Q to get the equation. So practice this for your midterms. I'm very sure it will be doable. So yep. So same goes to a question 2. You can take a screenshot for the answer. Question 2, I even plot the graph for your reference, just in case if you want to practice on how to plot the graph with the function given. So this is the answer for question A. Okay. And then this is the answer for question B. Answer for question C. Okay. So, yep, that's all for the practice for your midterms, and all the best for your midterms. Okay. Thank you.